Hi guys, how are you? I hope everything's fine. I hope that you all enjoying this course. So my name is Rafael de Carvalho Bueno. Unfortunately, I can't be here doing this live streaming, but I recorded this video especially for this course. I hope that it will not be a problem for you. I think if you have a question during my presentation, so this would be quite similar to the first part of the course, you can send a message in the chat and Lucas and André will try to help you. If you have more questions, so feel free to send me an email. You can contact me. I will be happy to help you with any kind of question that you have. Even those that is not related to Matplotlib, that is the package that we discussed in this part of the lecture, but also general questions about Python, so feel free to send me an email. In the end of this presentation, I want to show you some projects that I have done where I used Python not only to plot things or to calculate things, but to show you why Python is so powerful and to show how Python is flexible to do different things. For example, you can create a graphical user interface for your codes exactly as a software. That is a really good thing to do because you make your codes more accessible, even for those that don't have a skill with Python. You can also create maps, real maps, exporting shape files, for example. You can do similar things that you can do with ArcGIS. You can do with Python. Of course, you don't have that friendly interface, but if you work with Python, I think that is not a problem for you. You can also analyze image, videos. You can run PIV analysis. You can create games too. So there is a lot of options that you can do with Python. Because it's open source, so there is a lot of package available for different applications. You can also create your own package. This it's a really great advantage of Python. Of course, there is a disadvantage that is a little bit slow for heavy calculations. So for example, it's really hard to solve a differential equation using direct numerical simulation. So that's not a really good option for that solution, to obtain that solution, okay? But for general aspects, for most of our applications, I think Python is a really good choice. Okay, but right now we talk a little bit about graph visualization, why Python actually, which kind of package we need to use to make plots, to plot things, to make figures, to make animations. So actually there are plenty of graph visualization tools available that you can use to generate graphs, figures, animations. For example, you can export your data to external software. Of course, in that case, you have this additional work to do because you must deal with these data files. Actually, you must save that variables into a file and then export that to other software. That's not a smart way, even if, mainly when you are just using that to plot things or to do animation. So the best way is to do in the same environment that you are make your calculations. So the best way is to do that graph in the Python environment. And for this, we have the Matplotlib package. So the Matplotlib package is one of the most popular package for data visualization. It's a library for creating static, animated, and interactive visualization in Python. So all documentation is available in the Matplotlib website. So I will show you that website. So Matplotlib website. So it's that one. So here we can find the installation procedure if you want But if you are using Spider or Anaconda, that you use Spider, you don't need actually install that package. It's already there. We have all documentation, so here you can find all types of graph that you have. We have examples, tutorials, and also as Matplotlib is an open source package, you can also contribute to that package too. So here is the type of the sample plots in Matplotlib. So for example, here we have line plots, multi subplots in one figure. So this we'll cover in this part of the course. So this is extremely easy basic course. So we just cover base things related to Matplotlib. So we'll cover this one. You can process images. You can create heat maps. We can create histograms. We will discuss that too. We can create a three-dimensional plotting. We can create bar charts, pie charts, tables, scatter plots. If you deal with LaTeX, if you work with LaTeX, you can also include equations in TeX notation. So that's also a really good thing to do. If you have an equation, you can include that in the graph background. So there is a lot of things that you can do with Matplotlib. Okay, so what exactly we'll cover here? So we introduce here general concepts of data visualization and explain why the Matplotlib library is a good choice. So of course that is already there. We can see that because we can process and make your plots in the same environment. So this is the advantage. We don't need to export the data that can be three-dimensional metric. It's really hard to save it in a test file. So it's better to deal with this in the same environment that you calculate things. So we'll talk a little bit about simple plots, scatter graph, subplots, histograms, box plot, and animations. So we cover the base things here. Not, of course, we work this is a little bit different because you will work with data frames. That is the type of the graph generated by pandas. It's the type of variable generated by pandas. It's one of them. So this is a little bit different when you use just the Matplotlib plotting with, for example, with just an array or 2D array. So it's a little bit different, but not too much. So let's work. So first, as I said, I just want to say again, if you have already worked with pandas, if you have already worked with Matplotlib, but you have never worked with pandas, so you see a little difference to make a plot. So it's a little bit different because actually the subplot environment is the same, but when you call the function to plot it in the graph, it's a little bit different because we need to deal with a variable that has a type of data frame. Okay, so the type of that variable is data frame. So it's a little bit different. Okay, sorry. Okay, one thing that I want to say is that it's really hard to cover everything here because we can do a lot of things using Matplotlib. There is a lot of features that you can change in that environment. So for example, when you are plotting a figure, we can create subplots and you can change, for example, the background color of each graph. So this is just one change that I think it's not important, so I will not say that. But you can do much, we can do a lot of things that I will not say here in this course. Not because it's basic, but I think it's not necessary in this stage that we just want a high quality graph for a high quality graph. So there is no need for many of that features. But I just want to say that you can do a lot of things, okay? You can actually create or modify your graph in different ways. Okay, so let's start. Oh, sorry. Okay, guys, so we can start. I just want to make sure that the data that I have here is the same data that Lucas used in the first part of the course. I think it's the same, but I don't have all the calculations that he did. So I don't think that would be a problem, okay? So first thing to do is import the Matplotlib library. So import matplotlib.pyplot as plt, and then we can create the figure where we have our plots. So the first value, we must indicate the top level artist where holds all our plots, and then the second variable indicates the array of axes, or which means the location of each plot, okay? So this value will be a float value when you have only one graph inside a figure. That will be this first example case. But when you have multiplots, we'll see that this value will be a one or two dimensional arrays. So in this case, we must specify also the subplot function, and then the number of rows and the number of columns. Of course, since we are in this first example, you are just plotting one single graph inside a figure, so we have just one column and one row. This is the default value, so we don't need to specify that, but I'm just specifying just to make it a little bit clear. So we can specify, for example, the size of the figure. We don't need to do that because it's we have a default for that, but just to make it a little bit flexible for you in the future, so we can change that. So here we have the length, and the height of the figure. Okay, so now we can start to plot things inside that graph. So the first thing that we want to plot, for example, is a time series of air temperature. That is the first graph allocated in this data frame. So we call this data frame, that you have that variable, dot plot, and then we specify the kind of plot that you want to plot. Kind equal, it's a line type, okay? And then we specify also the variable that you want to plot. So in this case will be the air temperature value. So we just need to write the header name here. And then we can modify the color. We don't need to modify the color because there is because there is a default for that. But just to make it, just to change the default color. So we want to change it to black. So we must specify also the axis that we are using. So of course, we have only one graph, so we specify it as x as a single value that you have defined here. If you plot this one, we can see that you have our first graph. Of course, it's not good because we don't have y-axis label, we don't have x-axis label. We have this strange legend here because we must specify it as air temperature. So we can do that now. Okay, so Since we know the plot, so we specify the plot that you are using. Of course, now we have only that one. Dot set y axis label, set y label. In that case is air temperature. And then we can specify also the axis label and date. Okay, and then also change the name of the legend. So to change the name of the legend, we must specify here in the plot and the plot function the new argument that's called label. So we must change that value so we can change it to air. For example, if you have more stations of air temperature, you plot. You have a lot of different stations to plot at the same graph, so we can just specify it as station 1. Okay. So when you run this code, we have a better graph. But now we want to include in that same graph a new variable. So for example, we want to plot the wind speed. So to plot the wind speed, we can just copy this row here exactly, but change the y variable. So change to ws. So we are actually would be plotting the wind speed. But there is a smarter way. We can just change this y value, that's a single string, to a list of strings. So a list of string, so we can just type his as a ws, that's the wind speed variable, and of course we must change the color and the label to a list of string. So here we have, for example, red, and this label we can define a list to wind speed meters per second, for example. Okay, when you run this, so we have a new variable, but of course it's not a good plot because we are sharing the same y-axis for two different variables. So we have wind speed and air temperature. So the best way to deal with these two variables is, or we can create two plots, one for air temperature and a second one for wind speed, or we can create a second y-axis. So we'll do that firstly. Okay, so to do that, we must specify the second axis. So the second axis we can choose the name. So I specified here as x2, then equal to x, because this is part of this first graph, dot twin function. So the twin function, we want to share the axis, but create a second y-axis. So this is twin x because we're sharing the same axis, x-axis. Okay. So we have that. So now we must define the plot. So our variable that we want to plot is in this data file. So in file, we can just plot. Kind of the plot will be similar to that one. So line, and then we must specify the variable that we want to plot. So it's ws, and then the color. So we can specify it as a red. The label, we can define this as a wind speed in meters per second, and then the x that we use is the x2. Okay, so we must to use that one here. And of course you don't want to duplicate the wind speed variable, so I change that or exclude here the wind speed variable that we defined it before. Okay, then we can also specify the y-axis label. For example, here I can set, remember now we must to use the definition here for the second y-axis. So in this case we have x2 dot set y label, and in this case will be wind speed, for example, in meters per second. Okay, so we can try to plot. That's not good because you can't distinguish both values, and also we can see that we have only one legend here because one it's I think we have two, but we can't distinguish them because it's like that. So the best thing to do here is to change the range of our y-axis, this first one and this second one too. So for example, to do that we must define a new definition. So for the first plot, that is the first variable, that is the air temperature that we are using for the first y-axis. So it's x dot set y-lim, because it's limit of the y-axis, and then we must define. So our air temperature fluctuates from 22 to 34. So as we want to make it in the upper part, we want to move that variable to the upper part of the graph, so we can define that from 10 to 35. Okay, we can see actually if it's right or not, if it's good or not. So for the second variable, that is, we define it in the second y-axis, so that is the wind speed, we must to also specify a new limit. So the wind speed varies from 0 to 5, so we can specify we want that be in the lower part of the graph, so we can specify 0 to 10, for example. We duplicate the number, the value. And also we must to change the legend, the location of legend. So here we can specify the legend for the air temperature. So x dot legend, we can change the location of that legend. So the location we can, for example, define in upper right location, and we must define the legend for our second variable that is defined in the second y-axis, and we can specify it in, for example, in the lower left region. So when you plot this, we have this value here. So it's much better now. Okay, so now we can create the second plot. So if you want, for example, now include the variable of relative humidity in a second plot, not in the same one, not in the same graph. So you want to make the second graph, but in the same figure. So, of course, since we have also time series of relative humidity, it's better to define a subplot below, like one graph below the other. So I think it's better like that. So yeah, so let's start. So now I not create a new figure, I just modify that one. So for example, here we have the number of rows and the number of columns, right? So now we want to change to have 2 rows. So we must to specify, we must to change this. So 2 rows. And now this X value, it's not anymore a float number, but array of one dimension. So we must specify, we have two locations for that, the 0 position and the 1 position. So the first position, the second position. So we must specify our first graph as a first position with the first place of that list, of that array, sorry. So the first position is when you have index 0, so we must specify that as x0, and then also all variable that we use x in that figure, in that figure, no, but in that graph. So for example here x2 you don't need to change because it's already part of this x0, okay? But you must to change that one. We must to change the legend. We must to change the y label, and we must to change the x label function. Okay, if you try to plot this one, we'll see that we will get a blank graph below. So yeah, now we need to specify the data in this second plot. Okay, so to specify would be quite similar to this first part here. So we must to define which data frame you are using. So will be nfile dot plot, and then we specify the kind of the plot will be line, and then we specify the variable that you want to plot. So here will be relative humidity. And then we can change the color, but I'll not change, just to show you which color is the default value. Then specify the X that we are using for the second graph. For the second graph, so we must define it in the second position of X value. So this would be with the index 1. Okay. And then we can also include the y-axis label. So for that we can just type x, the second position, set y label, and then we can include the relative. Sorry. Yeah. And then I think is right. So now we can see that we have our second plot too, but we can also change this label. So we remember we must include the label in our plot function. So here it's our plot, so we must include the label. So label and relative humidity. Yeah. Something that I didn't say but I want to mention now is sometimes you don't have that legend. Sometimes you neglect this. So we have just the line and the y-axis and the second y-axis. So it's really hard to define, okay, if you have two lines and two y-axis, which line is actually air temperature and which one is wind speed. So for that, we can just modify the colors of one y-axis and also the ticks of this. So we can change the color of these values. So for that, we can just specify here in our function that we have the label of this y wind speed when you define that. So here we can include here a color, and then we can add, for example, the same color that you use to define this line, this plot. So the wind speed is red, so this value will be red. And also we can change the ticking the ticks. So we'll be change the values of this second y-axis. So for that, we can, for example, include x2 because it's the second axis, y-axis, and then tick parents, specify which axis do you want to modify, will be y-axis, and then we want to modify the color, so we can red. Sorry about that. I should mention that before. So there is a lot of things that you can change. So okay. So there is a lot of things that you can change. Okay, actually, if you see the difference here, if you have specify here as a color, we have done just the modification here in these values here, you know, not the number. But if you want the number, you must include the S. That is strange. So now we can see that you have both. It's red. Yeah, I was thinking that it was strange because it should be the number. Then I remember that I missed the S, and then I realized I saw that if you miss the S here, so you just change that value, not the number, not the color of the number. Okay, so another thing that sometimes is really good here when you have this interactive panel, sometimes you can zoom in or zoom out, but you can see that when I zoom in this first graph, this is we don't have that same patterns here. So I just seen this zoom in the first panel, in the first graph, but we can share the axis. So in subplot function here, when you define the figure, you can include, for example, the share property. So you can share the x or share the y, depends on what you want to share. But we can move change that the default value is false, but you can change that to true, and you see that now in this interactive panel, in this interactive graph, when you zoom in one specific graph, all of them will be also, you have that zoom, okay? But that function is not only good to when you have this interactive panel, but also when you want to keep the range of your y-axis, for example, or when you want to compare the magnitude of different plots, so you keep the range of y-axis the same for all graphs all plots that you have in the same figure. Okay, so now I want just to include something here, is you can also, when you have that kind of plots, sometimes we want to, for example, in a publication, we must to enumerate the subplots. So for that we can use the title function. So we can, for example, include for the first graph a title, set title, and we can enumerate that. So graph A, and the location of that, usually we define it in the left side, and then we can do similar thing to the second plot, but using B value. So we have that. So when we plot this, we have this condition here. Okay, Another thing that we must change is this data, this x-axis label, that since we define it here, you can think, okay, but you already defined it here, it's here, but it's defined for the first graph, so we can change that to be in the second graph. Okay, so now it's in the second graph. So, oh, it's not. No. I think it's there. Maybe I didn't close. Let's see. No? Whoa. Okay. Okay. Try again. Okay, so x1 set x label date. Yeah, it's there. It's there. I don't know why you had that, but yeah, now you can see. Okay, now we want to create a second figure. It's a simple scatter figure. For example, we can make a new figure. So we can define a new figure with the same variables, because we already used that, so you don't need to change the variable for that. So you can use fig and x as a new variable. So plt dot subplots, and then we have only one row and one column. We will not change the size of the figure, so I keep the default value. Inside of that figure, you have only one graph, so it's the reason that I'm not specifying here the number of rows and the number of columns. Okay, so for example, we use data from this data file again, so in file dot plot. Now we want to specify the kind of plot will be a scatter, and then now we have different values for x and y, so we must specify both variables. So for example, we can compare the air temperature, this value here, so we can include it in the x-axis, and then in the y-axis we can include relative humidity that should have the there is a correlation between them, or we should see that. Okay, so we can define also the color of our marks, so for example red, and then we can define the size. Remember that the size you can also change, you can also include it as a function, so we can change the size of your marks depend on something. Okay, so you can also include these variables here as a function, and also specify the graph that you are working. So we have only one, so it's the x value. It's a single float number. Okay, then we must specify, for example, the y-axis, the y-axis label. So y label, is relative humidity. I just copy that from here, and then x dot set x label for air temperature. So this one here. Okay, so we have that one. So yeah, this one here. If you have calculated many different things with Lucas, so probably we can include in this graph all the calculation that you perform in the first part of the course. So if you have the linear regression for that, you can include here. If you have the for example, the equation, so we can include it also in this plot. So there is a lot of things that you can include here, depend on the calculations that you performed in the first part of the course. Okay, so okay, now we can make a histogram. I think we would be, so we can start histogram. Oh, sorry. Okay, guys, sorry about that. So now we want to define our histogram. But before that, we should create two new data frame. Probably you have that new data frame that you calculate during the first part of the course, but just to make sure, I need to do that because I don't have that information here. Okay, so the first thing will be the monthly average value of our data. So we can define here monthly group, for example, then equal to the data frame that you want to take this average. So in file, group by, and then pd.grouper. You can also use resample here. The frequency is each month, and we want to take the mean. The second, we want to take and to create another data frame. This is the monthly average value, and the second data frame that you want to obtain is the average of all months, but combined for every year. You see the difference. So month group equal to in file, so the same data frame. Then here group by, but now we define the in file dot index dot month, each month, and the average. Okay, so we see the difference between these two data frames. So if you look here, we have two of them, so the monthly and the month group. As you can see here, the monthly, so we took the monthly average of our data, so air temperature, relative humidity, and then we have the value average for each month from 2002 to 2011, right? And the second data frame that you obtained is the average for each month. So for example, for all years, for example, we have January, February, and the average of that month during different years. So this varies from January to December. Okay, so this is the difference between both data frames. So now we create the figure. We want two plots. Okay, so one figure and two graphs inside that. So we define our figure, x exactly as before, plt dot subplots, and then we define the number of rows and columns. We want two columns. We want one graph and next to other. With fig size, we can define the fig size, the size of the figure. So it will be 10 and 5, and then we can make our histogram. So the histogram here, you use that data, so this new data, the monthly group, so monthly group dot plot, and the kind of the plot will be histogram. So ist, is defined as ist. And the y variable, the variable that I want to show in this histogram, is only the air temperature, for example. So the air temperature is that variable here, so we can just copy that. And then we define the position of our graph that will be in the first position. Okay. In the second graph, of course, I can define the label of the x-axis. So x first position dot set x label monthly air temperature. Okay. So the second graph will be a line type, but using the month group data frame. So using this dot plot kind of plot, you can change that, so we can show as a bar. There is no problem with this, but I'm showing as a line. If you want to show as a box, as a bar, sorry. So with a bar chart, you just change this as a bar. So we have a bar chart. So, but I want to line. And then we specify the value, the variable. So it will be the air temperature true. So it will be like that. And then we specify also the second position of our this is the second graph. So when we run this, you can also define the label here as before. So label here air temperature, for example, and here we can also define as air temperature too. We can also define the x-axis label, the y-axis label here, but okay, it's not right. Yeah. Okay, so here we have our plot. So as you can see, here we have the frequency. So we don't need to specify that because these are the full value. So this will be always, if you are plotting the histogram, always will be a frequency. So we have the monthly, monthly. Okay, so we have the monthly average air temperature. We can see that most part of the time we have our temperature between 25 and 26. Just a single few periods we have higher than 27, and also we can see that this temperature along different years we have higher values around 27 degrees, the average of that around the month of October. So it's around that you can combine. You can also add the x-axis label here, y-axis label here. We can change the label here. So there is no big deal with this. You just need to specify as we did before. I want to show you the box plot too. So the box plot will be we want actually a new figure. So fig x x and then plt and then dot subplots. We have only one graph inside that figure, so we don't need to be worried about that. So we want to have a box plot using data from, for example, this month group. So we can just use the month group dot plot, and then the kind of the plot will be box, and then X, we have only one figure, so we have the same value. Okay, so we can plot again, and now we have this box plot figure here. So as you can see, okay, I didn't specify which variable I want, so I plotted all variables that I have. So air temperature, relative humidity, so we have all temperature here, and the value is shared. So the variation, this varies from 0 to 100 because we have value that is related to wind speed and also to relative humidity that is much higher than the wind speed, right? So we can also specify here which variable you want to plot. So for example, if you want to plot just the wind speed, we should, for example, that variable here, and then we have the plot. So we plot only the wind speed. No, too much. So we have here. And you can also specify to have more subplots for different variables. So it's up to you to define more variables to show that. Okay. Okay, I think now maybe it's good to talk a little bit about animations. The animation is a little bit different than I have done because we have different package to do that. So for example, you can use the pandas alive, that is a package available, so we can combine the pandas with the animation. But so sorry guys, I need to answer a call here. I have worked actually with pandas alive, but I don't think it's a really good choice, not for me in my case, because I didn't find a way to make or to collect the data and plot it alive. For example, when I use Arduino or Raspberry, I collect data in real time. So I want to plot that data. And in my case, what I saw using pandas alive is that you must have your entire data to plot that as animation. But I don't know. Actually, I didn't try too much. But something that I have used is the animation model from Matplotlib. The only problem with this is that when you have time series, you must deal with date. That is not the way so easy that you can deal as when you work with pandas. Okay, so we don't have a lot of work to do with data when you use pandas, but in that case we must to have you must to spend a little time to work with data. So we have to import two models. So the first one is from Matplotlib, import animation, and the second one is to work with date. So import matplotlib dot dates as dates. Okay, the first thing that we must to do is convert our data to a number. So there is two manipulations that we must do. The first one is convert our data frame related to the timestamp with to string values. So for that, we use call date, and then we call our data frame dot index that we define it dot to by date time. And then this converted our data frame related to index, our timestamp, to a string values. But now we must to convert that string to a number. So this is done using the model mdates, actually the package. So we must call that, so mdates dot date to number or num, and then you have the value. Okay, now this date will be a number that the Python will recognize which day, which month, which year is that. Okay, so for each value, the Python or the Matplotlib will recognize which date or each time it's actually that value. Okay. Similar to that we did before, so we can define our figure. So fig x equal to plt.subplots. We don't need to specify here. We can use the default values, and then we must to define two lists. Okay, x data and the y data. We'll see after why you need to specify these two lists. So then we must define the background of the plot. So define line equal to plt.plot, and then specify the both locations. And then we need to create two functions. The first one is to define the initial condition of our plot. So def init, for example, and then we specify the conditions. So for example, we must specify the limit of our y-axis. So for example, exactly as we did in the first graph, set y-lim. We can plot, for example, air temperature. In that case, we have a range of 0 to 100. So this is the maximum range of in our case. So I do that. So I defined a range of from 0 to 100. And then also we can define the limit of x-axis. So in this case, lim. And then we can start from the first value, first date that you have information from. I not take the whole array because it's too large, so I just define the first 1000 values. Okay. Yeah. Then we must also to define the type of the data that you want to be plotted. Okay, which format do you want? So we can define that x-axis dot set major formatter, then mdates dot date formatter, this one, and then we must specify the type or the formatter that you want to be plotted. So for example, here we can define the month as a B, I think, and the day as a D. Okay, let's see. And then we must to include a return line. Okay, the second function will be the frame. So frame any, and then we define a counter for that. And then we have the first thing to do is actually extract the information from our rows that is defined in data frame. So we need to extract that rows. So local, it's any file dot iloc, because we extract information from there, and then we specify the counter for that. So will be 0, 2, 3, 4, 5, 6, 7, 8, and then you take each time step. Okay, you take the information from each time step. Okay, then we must to indicate the value related to this. So we must extract the information that you want. So if you are trying to plot something related to the relative humidity, so we must extract just information for that. So Y data, remember we defined this list here. So Y data dot append, and then local. So we want information of relative humidity, and then here we have, in that case, we have only a value. Actually, the type of this information, it's a series, so it's not good. We must have only the number, only the float relate to that relative humidity for that time. This relate to the index, to that index. So we must include that. Okay, so we extract just the value related to the relative humidity. Okay, and then we must also specify the date. So x date, data, x data append date, and we extract information at this time. And then line dot set data, x data, y data, and then return line. Okay, then we must define the most important thing, that is the animator. This is not anymore inside the function. Okay, animator. In that case, so animation dot func animation, exactly that. Then we define the fig that we define here. The frames, any, so is this function here. And then we can define the number of frames. The number of frames, 100, for example. We must define the initial condition. So init function should be init in this case. And it's fine, I think it's ready. So we can run this, and I just I don't want to plot everything again, so I comment these plots here. Okay. Oh, we got an error. Frame. Okay, this is frames. Okay. Here it's frames. Okay, this is frames, I think. Sorry. Try again. Yeah, now it didn't work. Name date is not defined. Okay, I commented this one. Oh, one more try. Oh my god. This is like that. One more. Yeah, now it's right. So as you can see here, we have an animated figure. Okay, my mistake that time. So you can see, you can also include all features that you want to include, and you have that data. Of course, this is we have only 100 frames, but if we increase that, so 1000. So now it's better. So we can see the values. I think it's that. If you have any question, if you want to do something different, so feel free to contact me. If you want to make different things, I know that I said that I would show you some project that I have done, but I think we don't have time to that. But I can show you like just a single thing that I did. For example, a software where you can run, and then you have all the graphical interface here where you can define everything, you can open. So there is a lot of things that we can do with Python. This is a graphical user interface that I did for one of my codes. So that's a really good, and I like it a lot. That so, but we have also we can import it, for example, shape files here to calculate the wind fetch. That is really use that shape files to calculate everything like that. So we can see that we can combine a numerical solution with graphical user interface, with things related to the shape files, and also we can create different things with Python. So that's a really powerful language. So I hope that you enjoyed that course, and is that. Thank you very much for your attention, and see you soon. And if you have any questions, so feel free to contact me. See you. Bye bye.